What is up, guys? Welcome back again. So today's topic will be doubly reinforced beams. So in this video we'll discuss why doubly reinforced beams are provided, and what is the concept of doubly reinforced beam, and we'll see some design problems based on doubly reinforced beams. So let's get started. Okay, so what is a doubly reinforced beam? A doubly reinforced beam is a beam that is reinforced on both the compression and the tension side. So what I meant to say was the steel is provided also on the compression side of the beam. Okay, so let's discuss why doubly reinforced beams are provided. Basically, when the dimension of the beam are restricted due to requirements as per the design requirements or appearance, etc. As the dimensions of the beams is restricted, the moment carrying capacity of the beam decreases, and hence it is necessary to provide doubly reinforced beams. And when moment required to carry is greater than the ultimate resistance of the beam, we provide doubly reinforced beam. And also when the bending moment changes sign, on a continuous support, the bending moment becomes negative, so in that case we have to provide reinforcement also on the compression side. And sometimes compression reinforcement is provided in the beams to reduce excessive deflections. So before we get started, let us first see the stress strain distribution diagram across a doubly reinforced beam. So the strain diagram is similar to what it was in the singly reinforced beam, and while the stress diagram is somewhat similar, but the compressive force will be a resultant of two forces, C1 and C2. C1 will be the compressive force due to the compression reinforcement provided on the compression side, while C2 will be the compressive force taken up by the concrete. Okay, so C1 will be the compressive force in the compression steel that will be acting at a distance d dash, that is the effective cover from the top side, and C2 again will be the compressive force in concrete. It will be acting at 0.42 times xu from the top of the beam, and the lever arm will be d minus 0.42 xu for C2, and for C1 it will be d minus d dash. Okay, so the total resultant force will be C equals C1 plus C2, wherein C1 will be FSC, that is the stress in compression steel, multiplied by its area, that is ASC, and the lever, okay, so that is the compressive force, and C2 will be 0.36 FCK XU times B. This is similar to the singly reinforced beam. Okay, so the moment of the doubly reinforced beam will be M1 plus M2. The value of M1 will be equal to the ultimate moment of resistance of the beam, that will be 0.36 FCK XU max B T minus 0.42 XU max, plus M2 will be the extra moment that the beam has to carry above the ultimate moment of resistance, which will be taken up by the compressive steel, that will be FSC times ASC, and the lever arm will be d minus d dash. So for the analysis purpose of doubly reinforced beam, we will use the steel beam theory. So in this theory, the beam is assumed to be divided into two parts. That is, the first beam is considered to be a singly reinforced beam which can sustain the ultimate moment of resistance, which is this beam, and the other beam is assumed to be having no concrete but only the tension steel and the compression steel. Okay, so I'll show you how it is done. So the total moment is mu, which the beam has to carry, which will be divided into two parts, mu limited plus m2. This moment will be taken up by this beam, and this moment will be taken up by the second beam. Okay, once you get the value of m2, you can calculate AST2 and ASC. I'll show you what are the formulas you have to remember for this. The first formula would be, which is for the singly reinforced beam, where XU is XU max. Again here XU is XU max. For m2, you can get m2 by deducting mu limited from mu. The first part of m2, that is for calculating AST2, would be 0.87 Fy AST2. The lever arm would be d minus d dash. Second part of m2 would be the compression steel, which is given by FSC into ASC. The lever arm is d minus d dash. Now let us see an actual problem on doubly reinforced beam. So the problem is, design a reinforced concrete beam of size 300 mm by 300 mm, which is the effective depth, to resist a ultimate moment of 87 kilonewton meter. Use M20 grade of concrete and Fe415 grade of steel. So let's start now. Always the basic step would be to calculate the value of ultimate or the limiting depth of neutral axis, that is XU max, and the actual XU. For Fe415 steel it is 0.48 D, so I got it as 149 mm. For now, the actual depth of neutral axis, will assume that this beam is a singly reinforced beam, because we don't know, because in the problem it is not given that it is a doubly reinforced beam. So I assume that it is a singly reinforced beam, and I found out the value of XU using the equation of moment of resistance for singly reinforced beam. So I got it as 535 mm, which is clearly greater than XU max. So this beam is an over reinforced beam. In limit state design, we never design the beam for beam as over reinforced beam. So this is a doubly reinforced beam. Always the first step would be to calculate the maximum the ultimate moment of resistance. So the main part starts here. Calculation of ultimate moment of resistance, which will be taken up by the first beam. Okay, 0.36 multiplied by FCK is 20, and XU max we already found out 159 mm, multiplied by the 300 is the width, again 300 is the depth, multiplied by 0.4 minus 0.42 into 159. So if we solve this, the value of ultimate moment of resistance is 74.5 kilonewton meter. Once you get the value of mu limited, we can calculate the value of m2. So the third step would be calculation of m2. Your total moment is made up of two moments, mu limited plus m2. So total moment is 87, and the ultimate moment is 74.5. So if you solve for m2, you get m2 as 12.5 kilonewton meter. Now you need the stress in compression steel and the stress in concrete at the level of the compression steel, which is given as FSC and FCC. This is the stress in compression steel. This you can find out by a formula 0.45 times FCK, which will be 0.45 multiplied by 20 is equal to 9 Newton per mm square. Now for calculating FSC, you need the d dash by d ratio. So in our case, d dash by d is 30 by 300, which is 0.1. Once you get this ratio, you can calculate the value of FSC for a particular grade of concrete by using the table. The table I'll show you somewhere here on the top. So by interpolating, you can calculate the value of FSC. For my case, for this grade of concrete and this d dash by d ratio, the FSC value is 412 Newton per mm square. So once you get this, we have to first find out the AST2. So the formula for AST2 would be M2 is equal to 0.87 Fy AST2. The lever arm is D minus D dash. Okay, so value of M2 is 12.5 into 10 raised to 6 equals 0.87 multiplied by 415. AST2 D is 300 minus 30. So if you solve for AST2, you can get the AST2 as 128 mm square. Then again, using M2, we will find out the value of ASC. M2 is given as FSC minus FCC into ASC multiplied by the lever arm is D minus D dash. Yeah, FSC is 412 minus 9 is the FCC value multiplied by ASC 300 minus 30. M2 is 12.5 into 10 raised to 6. So yeah, ASC value would be 104 mm square. Now you got AST2 and ASC, but we still do not have the value of AST1, which was for singly reinforced beam. So as we all know, we have the value of XU, which is the XU max, which is for the singly reinforced beam. We can calculate the value of AST1 using by equating CU and TU. CU equals to TU. So for singly reinforced beam it is 0.36 FCK. XU max B is equal to 0.87 Fy AST1. This was 159 multiplied by 300 equals 0.87 multiplied by 415 into AST1. So if you solve for AST1, you'll get AST1 value as 861 mm square. So total area of steel for the tension side will be the summation of AST1 and AST2. That would be 861 mm plus 128 mm. So the total would be 989 mm square. So after solving all this, we got AST as 989 mm square and ASC as 114 mm square. So this steel will be provided on the tension side, and this steel will be provided on the compression side. So that's all with the design and analysis of a double reinforced beam. I hope you liked the video. If you have any doubt, please comment down in the comment section. I post videos like this every day, and please share this video with your friends, and don't forget to like, share and subscribe. And till then, goodbye.